Hey everyone, Mr. Skelton here, back at it for Lesson 4, Unit 6, and today we're going to be talking about two types of interest, and I've already written them down on your notes. We're going to be talking about compound interest, and we're going to be talking about interest that is compounded continuously. And it all stems from what you have already learned from Lesson 1, which is y equals a times b to the x, which we use for exponential growth and decay. But for purposes of what we're doing here, when we're talking about interest and money, we're talking about growth. We want our money to grow. And so you should see a natural carryover from Lesson 1 and our basic formula to the two formulas that we're going to kind of generate today. So let's just jump right into it, and we'll kind of show you how this works, because there's a couple different ways you can think about it. So here's the situation right here. We have $4,000 in an account. It's making 12% interest. Nice interest rate there. And it's an interest, or it's being in the bank for 8 years. So we have 6 situations, and we're not going to get through all 6. We'll probably just get through the first 4. And I'm going to show you the difference in how your money is generating interest based on the time and the number of times interest is being generated. So the first one, compound annually, which means annually means once a year. And so if your money is generated once a year, this is the example that we did already in Lesson 1. That would be our $4,000, because remember, your A value is what you start with, right? This is your starting amount, which you already know. And so we have y equals $4,000. We're going to times that by our growth. How is it growing? Well, it's growing at an interest rate of 12%. So don't put 0.12 there. Remember, it's 1.12 because we have to include the 100% of our $4,000. And if it's being generated annually, which means one time a year, that means it's going to be, interest is going to be generated 8 times. So that's something that we did in Lesson 1. Let's take out our calculator, 1.12, and we're going to times that, not times it, 1.12 and raise it to the 8th power, times it by 4,000, and we get $9,903.85. Okay? So nice little deal there, and after an initial investment of $4,000. Now down at the bottom of this graph, this is not a 12, that's a 1. That 1 represents the number of times your money is generating the interest, and so it's annually, so it's one time a year, and this is the point, that's the roughly $9,903. That's the point there, okay? So let's jump into semi-annually. Semi-annually means twice a year. So annually means one time. I'll kind of put it in blue. Semi-annually means 2 times a year. So let's generate an equation that represents our money after it's being compounded twice a year. Well, our $4,000 is not going to change. We're still starting with that. Now, our interest rate is 12%. That doesn't change in terms of what we put here if it's compounded annually, but it's going to be semi-annually. So that means we need to take this 12% and break it in half, because it's twice a year, which means you're going to have 6% interest generated for the first 6 months, and then the second 6% for the second 6 months, and 6% plus 6% makes the 12. So the 12 is not changing, it's just how it's being applied to your money. So how many times is your interest being generated? Well, if it's twice a year over 8 years, twice a year over 8 years, you're going to have 16 times your money is being, interest is being generated. So we take our calculator, 1.06, we're going to raise that to the 16th power, and then we're going to times that by the 4,000, and we get a total of $10,161.40. So down here, again, that's not a 12, that's a 2, so semi-annually 2, there's your $10,161.40 roughly. Okay? Quarterly. Quarterly means 4 times a year, every quarter. So 4 times a year, we're starting with $4,000, and now it's quarterly. So what's happening to our 12%? Well, it's going to be 1.03, because we're going to have 3% interest for the first quarter, 3% interest for the second quarter, 3% interest for the third quarter, and 3% interest for the fourth quarter. And if you take those 3%, 3%, 3%, 3%, that makes 12%. Now, 4 times a year over 8 years means your money is going to generate interest 32 times. So let's take our calculator, 1.03. We're going to raise that to the 32nd power. We're going to times that by $4,000. And so we get $10,300 and basically 33 cents. Okay, so this 4 is representing your compound interest 4 times a year, and the point, there's your $10,300.33. Last one we'll do is monthly. So, you can think of, you're probably thinking, well, why are these all different, right? Well, these could be competing banks. Let's say you go to Bank A, and they're going to say, we're going to generate your money annually. You go to Bank B, they're like, oh, we're a competitive bank. Instead of annually, we'll give you semi-annual interest. And this Bank C could say, okay, we're going to give you your money generating interest 4 times a year or compounded quarterly. So these are kind of situational things that banks could offer, and we're just generating the dollar amounts to see which one is better for you. So let's say you go to a bank, Bank D or Bank 4, fourth bank in town, and you say, okay, here's my money, and they say, we'll give it to you compounded monthly. So what does that mean? That means your $4,000 is going to have an interest rate of 1% generated 12 times, because remember that 12% is not changing for all these banks. It's just how many times that 12% is being broken down and generated over time of a year. So it's 1%, because 1%, 1%, 1%, all 12 times, that's going to give you your 12. So it's generated monthly, so it's 12 times over 8 years. So 12 times 8, I believe, is 96. So we're going to go 1.01 to the 96th power, and we're going to times that by 4,000. 1, 2, 3, and that gives me $10,397.09. Okay, and so there's your monthly right there. That is a 12, and that's right there. Now, what do you notice graphically? What's going to happen if we continue to do this with daily and hourly? You would see that your money is going to start to reach a limit. This line right here is kind of the limit. It's that horizontal asymptote. Your money is going to get generated either annually, semi-annually, quarterly, monthly, but when you get to daily and hourly, it's going to start to just hit that plateau where it's not really going to get any higher. Okay? So I wanted to show you this because some students are going to understand how to generate these decimals and understand what to put in terms of the exponent. If you don't, if you were having a hard time kind of understanding what I was doing there, we have a couple formulas for you. What we were just doing is compound interest, and this is the compound interest formula. All right? And here's what each letter represents. P is the principal, so that's what you start with. That's your starting amount. Okay? R is your interest rate as a decimal, so we were using 12%, right? So 0.12. N is the number of times it's compounded in a year, and T represents the number of years. So let's take one of these situations. Let's take the compounded quarterly. So let's off here, we got our $4,000, right? It's at 12%, and it's quarterly. I'll just put quarterly. So let's plug that into this formula. Oops, if I can get on the page here. Let's plug it into the formula, and you'll see that it's the same exact thing we did. So we got Y equals, P is our $4,000. This is the number 1. 1 plus our rate was 12%. We got to write it as a decimal, so 0.12, over the number of times it's compounded, so 4 times because it's quarterly, and then 4 again times the number of years, 8. And so we would take our calculator, and some students are going to wonder what they do first. Remember, always do what's inside the parentheses first. You have division inside the parentheses, so it'd be point. Get my calculator here so you can maybe see it. Get the glare out of the way. 0.12 divided by 4, hit equals, and then add that to 1, hit equals. So that takes care of the parentheses. Now look at my calculator. 1.03. Go back to the front page. What was it for quarterly? 1.03. You can see the bottom left-hand corner. So you basically have now your 4,000 times 1.03 to the 32nd power. And that's exactly what we had here. Oops, if I can show you right here for compounded quarterly. Okay? So those of you who can't, kind of do it mentally and have that number sense, and that's totally fine, here's the formula you stick with compound interest. Okay? Now, we were working our way towards, if you look at this list, 1 through 6, get on the paper, once a year, twice a year, 4 times a year. Monthly was 12 times a year. Daily is going to be 365. Hourly, the number of hours in a year, we could calculate that. But what are we working towards? We're working towards continuously, okay? Continuously, which means your money is being generated all the time, 24/7, all the time, continuously. And when money is generated continuously, we used this formula right here. This is compound continuously. That is the formula you would use. Now, P is still what you start with. R and T are the same as it is up here. R is your rate as a decimal, important as a decimal, and T is time. The only thing that's new to you is this E. E is actually a number. E is like pi, right? Pi is 3.1415, etc. E is a number. And if you look at your graphing calculator here, I'll put it on here, you can see E is right here, e to the x, all right? And you're going to be using that button on your calculator. It's on a graphing calculator, it's also on a scientific calculator, okay? So let's use both of these formulas. And you may be wondering, how do you know when to use compounded continuously? You'll see it right in the question. Here are 2 questions, and if you just look at them, compounded continuously. As soon as you see that word continuously, you know you're using PERT. Sometimes we call it the PERT formula, P-E-R-T, PERT formula. So what I want you to do next is I want you to hit pause, and I want you to try both of these questions on your own, see what you come up with, and then hit play, and I'll walk you through the last 2. Okay, so let's take a look at number 1 here. How much would you have in an account that makes 8% interest compounded quarterly? I always like to write how many times a year for. If you invest $800 6 years ago. So if we use our formula, so y equals P1 plus R over N to the N times T, let's plug it in. If you can do this like we did on the very first part of the notes, go for it. So it's y equals, my principal is $800. It's 1 plus my rate, my interest rate is 0.08, that's 8% as a decimal. It's compounded quarterly, so remember N means how many times it's compounded, and it's 4 times the time 6 years ago, which would be 6. So what do you get? You get y equals 800. We should get 1.02. Now some of you, if you know that if you take 8% and that interest is broken up 4 times or divided, that 8% is divided 4 times, you know you're going to get 2% interest to the 24th. So we take our calculator, 1.02 raised to the 24th power, and we're going to times that by 800, and we get $1,286.74. Not bad. Okay? So number 2 is, kind of already talked about it. It says continuous. That's when you know you're going to use y equals P-E-R to the T, your PERT formula. So what do we have? It says $1,000, so that's what we're starting with. E is a number, so we just leave it as E. Our rate is 9%, so 0.09, and it says over 8 years ago, so we'll times that by 8. Now, what you need to do in your calculator here, we just got to be a little bit careful, make sure we do things in the correct order. What I'm going to do is, I'll probably zoom out here so you can see me hit the buttons. There we go. So I'm going to go second ln, which gives me my E. And it's already got a parenthesis, so 0.09 times 8, close the parenthesis. So that just took care of this part right here, because remember you have to do exponents first. So hit equals, and then we'll times that by 1,000. And you get $2,054.43. Okay? And that's all we're doing, folks. Compound interest, whether it's quarterly or monthly or semi-annually or compounded continuously. Those are your 2 formulas. Look forward to helping you out in class. If you have questions over anything, I'll be happy to reteach it to you until you feel comfortable with it. All right? Take care.